How do we calculate molar mass? Well, when we're just talking about elements themselves, if you look at the periodic table and you look for the specific element, you'll always find the molar mass listed at the bottom. So for oxygen, it's 15.999, often just rounded up to 16. For carbon, it's 12.011. For sulfur, you'll find it's 32.06. But these are pretty easy. What do we do when we have to find the molar mass for a molecule or a compound? Well, let's start with this example, NaBr. So we want to look at the periodic table and find Na and Br. So we can see that we only have one Na and we only have one Br. So all you have to do is add up 22.99 plus 79.904. So we know that the molar mass of Na is 22.99, molar mass of Br is 79.904, and if you add that together, you should come up with 102.894 grams per mole. That's the weight of 1 mole of this compound. Let's look at another example. Here we have CaCOH. So that's calcium, carbon, oxygen, hydrogen. So let's see. Calcium, oxygen, carbon, and hydrogen. Now we just have one of each of them, so it's pretty simple. We just have to add these up. And once you add all of these together, you should come up with 69.096 grams per mole. There are 69.096 grams in 1 mole of this compound. So let's look at an example that's a little bit different. Here, you're going to find that we have multiple atoms of the same element. So let's see how we tackle that. First, we have carbon, hydrogen, and oxygen. So let's write it out the way we normally would. We have carbon, hydrogen, and oxygen. But here we have 6 carbon, so we're just going to do 6 times the molar mass of one atom, which is 12.011. And then we have 12 hydrogen, so we're going to do 12 times 1.008. And we have 6 oxygen, so we're going to do 6 times 15.999. So if you do the math for all these parentheses and then you add up the answers together, you should come up with 180.156 grams per mole. After you multiply this, multiply this, multiply this, and then add all 3 answers together. Let's look at an example where we have to deal with parentheses. So let's start by identifying the elements we're working with. We have Ca, O, and H. Now, what we're going to have to do here is distribute this 2 to everything in the parentheses. So distribute the 2 to the O and to the H when we add all this together. So let's start by just writing the Ca down because that won't change. Ca is just 1, 40.078. Put this down here. And then O, we now have 2 because we have to distribute this 2. So O, we're going to have 2 times 15.999. Put this back up here. Then we can add our 2 hydrogens. So we have 2 hydrogens, and each of those weigh 1.008, as we can see here. So we're going to multiply this stuff in parentheses first, and this will give you 31.998, and this will give you 2.016, and then you're just going to add this, this, and this together to find the molar mass, which should be 74.092 grams per mole. Okay, so let's look at this problem. So in this one, we're going to have to distribute this 2 to everything in the parentheses, but you'll probably see that since we have a 4 here, 2 times 4 is going to give us 8 hydrogen atoms. So we have nitrogen, hydrogen, and sulfate. So let's start with our nitrogen. Nitrogen, we have 2 of them. 2 times 14.007. Hydrogen, 4 times 2 is 8 times 1.008. And we just have 1 sulfur. And that's 32.06. So I'll multiply this here, multiply that. You'll get your answers for these 2 problems, and then add this, this, and this together, and it should give you 68.138 grams per mole. Any questions? Comment below.